Hey there. I have a bit of a progress update style video here. Been working on some things, enums mostly, and then a little bit of a side quest into this world of type classes, so a facility for abstraction. Um, I wanted this because I wanted to derive equals functions for enums and structs, actually, because the enums can contain any types of structs too. But I didn't really have a place to put the code. And I wasn't really happy with the way I was doing just putting a fun equals inside of the namespaces and looking it up, hard coding that. So I decided let's just do it and see how it goes. So we have that. Taking a step back though from the abilities, aka the type classes, um, I'll look at a little bit. I did these tags. So these are like Lisp symbols, not quite, because they don't evaluate to themselves the whole Lisp thing, um, but it's kind of like something to use instead of a string as a good constant, and without having to like name integer constants to be like constant red equals 3 or whatever. So under the covers, every tag, these are called tags, every tag is just a 64-bit value. And I just sort of assign them linearly when I compile the program. So they're not guaranteed to have a particular value, which is, so it's not great for systems programming. It's not like that, like this can actually represent this byte, although maybe I could toy with letting you do that. But the idea was just to have these stable identifiers. And they have types. So the type of dot red is dot red, and the dot is how I've chosen to represent these tags. So in Clojure it's a colon, and in Lisp it might be a quote, or in some languages like a hash. So I'm using dot here. They're not super useful on their own, but they're sort of the building block for enums. They're how I'm tagging unions. I may throw this away as a thing that's standalone and just have the tags and unions be the only place that there are tags. Um, but because I'm allowing anonymous enums, I thought that having this consistent tag representation, I might need it, but it turns out I don't really. So anyway, it's still kind of neat. You can't really do too much with it. There's also a parent type. There will be a parent type called tag. So this will also work. So if you have like, you could have 3 tags and you could like check which one it is, instead of comparing like a bunch of strings. So they're just constants that are named. I'm really not sure it's that good or useful, but I implemented it pretty well, and it was nice to sort of run something through the whole compiler. So you can see here in the LLVM, tag.red is the constant 0, and tag.a is the constant 1. These just get assigned out based on all the ones that appear in the program. So I did implement equality on them, which leads us to enums. So here's an enum with no payloads. So I decided to support this anonymous syntax, so they don't have to be named, which is fun, but leads to some problems. I think it's really nice though. A lot of enums in practice, I find that a lot of enums are only useful in one context, and I want to use them there and then never again, like as a return type of a function, sort of like a ad hoc either or result type, but maybe it has a third variant or something. I don't want to name that thing. I just want it to be the return type, so fun get config returns doesn't have to return either config or something. It can just return enum config, uh, and the syntax would be enum config, like, or config load error that could have in a string, and you just do it right there. And then how do I refer to this type later? That's the thing. Like if you do want to refer to this type, then you kind of wish you'd named it and you'll have to name it. But um, I think I'm going to support talking about a function's return type like this. Maybe not this syntax. Dot, result type or dot return type. I haven't decided on a syntax, but why not? Why can't we talk about why can't we have richer type expressions, basically? The return type of a function, why can't that be a valid type expression? I see no reason not to. Um, it it similarly, it's the same thing as that's not even my language. I think it would just be like this type with a struct. So you might have type, and the type is enum, big, small, or ethereal. I don't even know if I spelled that right. That's also another way to do it. And then there's also an H, and that's an N, right? So this is something. And I don't want to name this. I don't want enum something type. Like that's this kind of noise. In TypeScript, if you've ever done this, like you can just do the inline object. And it's actually kind of nice because that object really only makes sense inside this thing. So why do I have to give everything a name? And then, you could certainly do, in TypeScript, we could say like something type. I hate this syntax because it looks like a runtime like field access, but this would evaluate to enum big, small, ethereal. It's the same type. So we don't have to name it if we have richer type expressions. So something dot type. Yeah, I haven't decided on syntax, but I certainly want this to be possible. I want to be able to talk about to reach into a struct and say, hey, the type of this member, just a type expression like that. Same thing with a function, a return type. Maybe you could do the type of a function's first argument or second argument. I'm not sure. I think that'd be really neat. I think that all just evaluates the compile time, so it wouldn't be too bad. It wouldn't complicate the runtime at all. So that's my idea behind these enums. I want them to be unnamed or anonymous if you want them to be unnamed. And we'll just see how that runs. Might be a bad idea, but that's the fun here. Like this is something I think I want, and I just want to play with it. Now you can do this. You can do this in some languages, like in TypeScript, you just have unions, and they can be anonymous. So you could just like make a union right there, and it's kind of nice. Except in this case, we're going to compile down to something fast and static, as if you'd pre-declared the enum. It's going to be no different in the machine code. So that's enums. Now the syntax here, what goes here? This actually isn't valid because I don't do tuples yet. That what can go here is just a type expression. So, it could be a wrapper for a string, but if you wanted to do multiple, I'm just going to make you do a struct because I think it's weird. Like tuple structs, you end up wanting to name it anyway. Tuples are great as building blocks, but they suck to use in software and in applications because accessing things by position just sucks. So it'll probably just be like you just make a record type here, and so this would be, I don't know what we had. We had a message. Let's say we have a message string and we have a code int, and we even have a no, error code is like there's two. There's maybe there's IO bad and terrible, right? You wouldn't do this. Maybe it'd be like this. Sorry. All right. And that's an inline enum, right? And I never care about this code. How would I access that? It would be like get config. Once I'm talking about this type return, let's say we do dot return type, and then that would be dot code, and then that's the type. So I just do val x, and that's equal to dot bat. Now I'm just making stuff up here. Some of this is working, so everything not in green, everything that maybe I'll keep some of this just as like a some design revision, but this is what's working. So we do have enums. None of these have tags, right? So this just becomes the way the tags are represented is U64. I know this could be 1 byte, but I'm just doing it all. The discriminant's always just a full word, and that's how it represents. So we can open up enum no payload, enum no payload dot the LLVM for this. You can see, look, I'm naming the structs now in the LLVM, which I super love. I need to name the overall enum too, so I need it's just a little bit complicated to generate the name here. But this would be, you know, even if we didn't pick a name, even if it was just the type ID, at least we'd have it, and it would be co-positioned. But you can see they're both the same representation, and then there's really not much else to it. We can see enum tag yes. It's just a struct. The way it works is well, it's simple in this case. So let's go to enum payload case. So this type can either be nope with no payload, certainly with a character, or absolutely with a string. So all of these are laid out. They start with the discriminant, of course, to the first 64 bits. And then, well, I can just show you. Sorry, LVM. So the first one, I64, I8, the other I64, the other I64, and then this is string. So we allocate enough space for the largest, and what's sad is I haven't actually defined that type here as an anonymous one, so you can't read it, but that's gonna be I64, and then an array. Yeah, see, so and then 122 times I1 is how I chose to represent the padding. So asdif, the local, the alloca for asdif, because it's, you know, it's of type baby, is just this generic shape. And then once we check the, when we load it and we check the discriminant, we see, oh, it's a dot certainly. So I'm going to interpret that as this struct, and I'm going to get this, you know, second element and expect that to be a byte. And that's just how it works. Just a tag union, just like how they work in Rust. But I implemented them and they work. So I can walk through this in the debugger and I can see the values, but I can't check for equality. I can't do anything with them, which is where we're going next, where I got tired of how equals worked and I didn't want to generate crappy, stupid like equality code, so I decided to do type classes. But real quick here, I think I should probably prove that something's working. So I can cargo test and everything is going to pass except array equality, because with my type class implementation, array equality is not done yet. Now, worth mentioning, string equality is working, and this is no longer using the hard-coded equals check, but this is using this ability equals, and then let's say impl equals for string down here, and this is intern, so it's still implemented by the compiler, but the lookup and the actual resolution of it is all based on the type class or the ability. So that is really neat. Array, I'll just go ahead and array's not working yet because array has a generic, and so I just didn't bother yet. It may work, it may not yet. There's probably some work there, but yeah, I labeled that one hard mode. Yeah, let's do the debugger. So I'll run. I'm not getting autocomplete, so I know that I've done something wrong. Oh, it's not in test source yet. It's just right here. And we'll go ahead and LLDB get fell out. I'm feeling lucky. Took some time. So now we're going to break at, and I can now, it knows the different files. So this is line 7. So I can break at, I think I can break at prelude.bfl. Let's do line 4. I know I've done this before. Ah, yes. We did it. So that's a breakpoint at line 4. Here's line 4. And here we are. So we'll just run frame variable. I did go ahead and do the debug info for these. It's using the full render for the type name, which is terrible. So I'm amazed this even works. But we can step, we can frame variable, step, and I haven't done the full debug info, just the discriminant. So it's not interpreting the struct shape, but we see that they all have different tags here. So I do think it's working, but I'm not really sure it's working. And I decided, like, let me just go ahead and implement equality and like inspect these things and go the whole 9 yards. So that's a quick demo of enums with payloads. And now, real quickly, just abilities. So this is all there is to it. An ability, right now I only support functions. It'll be pretty easy to put values in there or constants, but I'm not really concerned about it. I really want the functions. I want to be able to do a hash table soon, so this is exciting. Anyway, here's equals. Exactly what you think. Self is a special keyword that's bound in inside this scope. And within here, yeah, it's just a type variable. So now, and then if I say impl equals 4, the thing that goes here gets bound to self, and then it's required that that is used there. I can actually mess this up and let's run, which program is this? Oh, I guess it doesn't matter. I think I've been running string equality. Cannot resolve intrinsic function type for equals because of the type. Because I'm relying on that string to know that that's equals. That's specific to this intern. It's actually specific to string equals, so not as important. But here we go. Didn't match. I need to fix this error, but we expected string but got int when we were resolving the implementation against the so the only reason we would have expected string is if we substituted self, because we're comparing this definition to this definition. So we must have done this substitution, and then we expected a string but got int. So that's exactly what we want. String here, and then the return type we check the same. And if it works, then we let's do type to module, show what I've done, some refactoring around this, which doesn't really matter, but all we really needed for abilities is abilities and implementations. So a typed ability says the name, the functions, this is the definitions. So at this point, we just need function ID to point to, and then the name, which is a little bit extra, but really nice to have in here. So I kept it in here, and then scope. This is just the scope of this thing. It has its own scope. It also exists within a scope, but and then its definition ID. This should not be AST definition ID. This should be like type parsed ability ID. Because I'm not using like proper wrappers, I'm doing this like really loose type alias thing. Sometimes I have like the wrong type aliases. Probably it's to make these into struct wrappers. Yeah, and then it points to its AST node. So now that everything in the AST has a typed node, I can point things like this ability to their AST node, which is really, really nice and removed a lot of annoyingness. So that's good. And then, so we have abilities, and then we have implementations here. So it's just the ability implementation. So for the type, a given type and ability, these are the actual function implementations. And so the order is consistent. Is how we know which function's which. So we simply like zip them up and then type check each one. So the implementation here, actually, I can do a little dump. So if I cargo run source string equals, and I run dump module. Dump AST. Looks like it's dump module. Main. Huh. At typer 238184. Looks like an old. Ah. I removed the function. And so then what I got was a panic here where I say that I actually know that the equals ability has one function called equals. So not even mad about that. I just want to dump the module and show also this new dump I have. So coming up to the top here, this is familiar. We have the module name string equals, which is the name of the program. So we have our types, which a lot of array T's will fix that. We have our namespaces, root files, char array string, variables, every variable in the program. This is the least useful. I probably will stop printing this. Functions, which is quite nice. And then scopes. This is exciting. So we have root. We can see all the namespaces that live in root, all the types. I guess there's no types in root scope because they're just hard-coded, any that are root. Anyway, and then within root, any of the scopes. So BFL chart a string as a function has a scope. And inside BFL chart a string, there's a variable called C of type character. And then types. I'm printing types even if there's no types. But this is what's nice about types. See, we have equals. So this is the ability. The scope of the ability equals actually. So the scope of the ability equals has one function in it. And there's a type in that scope, which is self, and it's bound to the type variable self. So now, when I have problems with scopes, which are like recursive and tricky, I can look at them, which is super nice and has already helped me, and I'm excited. I'm glad I have it. Well, I think that's it for the progress I've made. I just things are starting to come together, and when this equals function worked, I felt like I should log a little bit the progress. It's been a bit of a winding path here, but I'm pretty excited that I got this to work, and kind of dreading the array T here, getting that to work within generic context. But anyway, that's all for today. See you next time.